video is going to take you the whole process through any question you could get on a limiting reactant, or if you see on your paper, limiting reagent problem. Please feel free to ask the sub to pause this video if you need. I've also will be posting this onto the wiki if you want to watch it again. I am only going to work out example 1, so the very first question, and then your goal will be to do 2, 3, and 4 as additional practice. And then this will be due next week. So here we go. Make sure you read everything that you're being asked to find. And so for all 4 of these questions, the things you're looking for are listed right there in A, B, C, and D, those parts. The first of those 4 things is determine the limiting reagent. And you need to be able to justify your answer. And what that means is through the math. So you need to be able to show me or prove your answer of your limiting reagent through the math, not just by taking a 50-50 guess, knowing that it has to be one of these 2 things. So we double check to make sure our equation's balanced. It is. And if you remember, the way we find limiting reactant is by taking both of our reactants to one of the products and seeing which one will make the least. Because once we get to the least amount of a product, we've run out of one of our reactants or one of our ingredients, if you will. So it doesn't matter which reactant you take it to, as long as you do the same one. And another thing to kind of keep in mind is everything on this assignment is given to you in moles. Everything is in moles. So that makes it a little bit easier because you do not have to calculate molar mass of anything. If we start with 0.15 moles of aluminum hydroxide and 0.41 moles of hydrochloric acid, we want to figure out what is the limiting reactant. So we can just do a mole-to-mole conversion and to one of the products, it doesn't matter which one, and see which one of these reactants limits the equation. I selected H2O as the product that I'm going to go to. So I'm going to take both of these and do a mole-to-mole problem to see which one limits the reaction. So to start, we'll do the AlOH3 guy. The mole ratio between aluminum hydroxide and water is, of course, 1 to 3. So for every 1 mole of aluminum hydroxide, we get 3 moles of water. So let me go ahead and do that mole-to-mole problem. Take what I'm starting with of aluminum hydroxide, which is that 0.15 moles. Set up your dimensional analysis using train tracks or parentheses, whichever makes you more comfortable. We do 1 mole down here. So that's the 1 mole of the AlOH3. Excuse my bad penmanship. And 3 moles of H2O up here. When we crunch this number, we find that we can produce 0.45 moles of water if we started with 0.15 moles of aluminum hydroxide. So that's only half the story. We have to do the same thing with the other reactant, which is this HCl guy. So let me scoot our screen up just a smidge. The other reactant is the HCl. We're starting with 0.41 moles of it. The mole ratio between hydrochloric acid and water is 3 to 3, or you could say 1 to 1 if that makes you happy. So 3 moles of HCl in gives us 3 moles of H2O out. So if I take my starting amount, 0.41 moles of HCl, and I do my dimensional analysis, I'll use train tracks this time. Plug in my mole ratio. We put the HCl on the bottom and the H2O up top. Well, of course, 3 over 3 is going to cancel each other out, so I end up just getting 0.41 moles of HCl. So now that I have these two numbers, let me change this so we can see. We have these two numbers to compare which one gives us the smallest amount. Of course, it's this guy. This number is smaller than 0.45, which that tells me that HCl is my limiting reactant. So this is the limiting reactant. That is our limiting reactant, which answers question A. Remember, we have 4 parts, so that answers question A, that hydrochloric acid is the limiting reactant. So let's continue on. Question B says, determine the amount of excess reagent used. Well, let's kind of look back at our formula here. We said that HCl is the limiting reactant, which means that aluminum hydroxide must be the excess. So what I need to know is, as I'm using up all of that HCl, all of my limiting reactant, how much aluminum hydroxide did I use? So I'm going to do another mole-to-mole problem. I'm going to start from my limiting reactant, and I'm going to figure out how much aluminum hydroxide I used up. So let's do that. The mole ratio between HCl and aluminum hydroxide is 1 mole of aluminum hydroxide will give us 3 moles of hydrochloric acid. So if I take my starting number, which was given to us in the question, of my limiting reactant, HCl, we had 0.41 moles of hydrochloric acid. Use my mole ratio, get my moles hydrochloric acid down here, so we cancel out all nice. Put moles of aluminum hydroxide up here. And we do the math, we come up with, what did I get here? I get 0.137 moles of aluminum hydroxide. So what that means is, oops, oh goodness, see if I can squeeze that 3 in there. That means that as I was using up all of that, as I was using up my limiting reactant, because remember, it's like the ingredient that we use up completely. So as I used it all up, it took this amount of aluminum hydroxide. So that is how much I used, how much of my excess I used, which answers, let's pick a better color here, pink, which answers question B. So there is the answer to B. That's how much I used up of the excess. Well, question C says, how much is left over? Determine the amount of excess left. If this is the amount that I used, how much is left over? Well, it depends on how much you started with. And the amount that you started with, if you go back, is given to you in the question, right? Here. That's the amount that you started with, is 0.15 moles. So I started with 0.15 moles of aluminum hydroxide. I used 0.137 moles. So just by simply subtracting, you'll find that the amount you have left, I get 0.013 moles of aluminum hydroxide. And this is what is left over. So that guy, oh, let's do a different color. That answers part C of this question. And then lastly, it says determine the amount of each product made. Well, no big deal, because if you recall, limiting reactants what drives the amount of products that you can produce. So you have already figured out how much product you can make, and I just noticed that I made a little error right here. Let's get rid of that. This should be H2O. There we go. You've already determined the amount of one of the products right there. So that's one of the product amounts that you can make. So all you have to do now is figure out how much of the other product can you make. And if the limiting reactant determines how much product we can make, we've already figured out how much H2O we can make. Now we just need to know how much aluminum chloride we can make. How much aluminum chloride will be produced? Well, the mole ratio between those two guys is 3 to 1. So, excuse me, and get some fresh page here. For every 3 moles HCl, I get 1 mole aluminum chloride. I'm starting with 0.41 moles of hydrochloric acid. That's my limiting reactant. And I use my mole ratio. So we get 3 down here, 3 moles HCl, 1 mole AlCl3 on top. You do your math, and we come up with 0.137. And this is similar to an example we looked at the other day in class, where we had a number that looked the same as something we had gotten before, and that is just purely coincidental. The fact that this number is the same as one that we calculated earlier in this problem, it works out to be just straight up coincidence, so don't count on the fact that you're going to always see similar numbers. Okay, so this answers part of D, because that tells us how much of that product we can make, and we had actually already, way up here somewhere, figured out that we could make that much water. So there's the other answer to D. So your goal is to do questions 2, 3, and 4. This video will be posted as a link on the wiki channel, so you can go there and watch it if you need to see the examples again. There's also some other video links posted out there. Don't forget that your UT Quest 6 and 7, as well as any UT Quest redos that you're going to try to attempt, are due tonight. So make sure you take care of that tonight by midnight. Thank you guys. Have a good weekend.